official lesson of the school year, 1.1, Solving Simple Equations. A lot of this is going to be review, but I really want you to go ahead and go through it. A couple things to keep in mind. You should have printed out blank notes, and as we go through this, there'll be times where I'll stop and I'll expect you to try the problem on your own. That's the best way that you can learn this is by doing it yourself. And then, of course, if you're stuck, I'll go through the problems. But really important that you get in the habit of doing that. Yes, I know that we're starting with stuff that's pretty basic, but certainly even in this unit, we'll get into material that will be brand new for you. And it's important that you do a good job of showing your work and really taking full advantage of these lesson videos and trying it yourself, being an active learner rather than just being passive. Okay, so why don't you go ahead and try these 6 warm-up problems. So go ahead and pause the video, try them, and then I'll go through them in a minute. Okay, I'm back here. So obviously 5 combined with negative 15. You really want to get away from writing 2 signs between terms. Terms are things that are added and subtracted together. Kind of think of them like blobs of numbers that are added or subtracted or standalone. And so plus and negative 5, really what I want you to get in the habit of doing is writing that as 5 and negative 15. And then if you want to, you can think of it, I'm combining positive 5 and negative 15 together. And as you know, when you add 2 numbers, you take the sign of the one that has the bigger absolute value. Bigger absolute value is the negative 15 in this case. So we're going to take a negative sign and then subtract the smaller absolute value 5 from the bigger one, 15, and you get negative 10. Okay, number 2, again, you want to think of this as 6 minus 7. I know you probably realize that's negative 1, but I want you to think of it as I'm combining 6 and negative 7 together. And I'm adding them. Combining means add. Again, take the negative because that's the bigger absolute value. And remember, absolute value is the distance away from 0. And then 7 minus 6 is negative 1. Okay, number 3, remember multiplication. What's the rule for whether you're going to get a product meaning the result of multiplication, if you have an odd number of negatives being multiplied together, like 1, 3, 5, and so forth? Right, you're going to get a negative. So this one ends up being negative 10. Same rule for division. Here we have 1, which is an odd number, 1 negative. So when we divide that, we get negative 15. What's the rule when you multiply times 0? Anything times 0 is equal to, hopefully you said 0. And then alter this one. No 2 signs between negatives. That's definitely an elementary school pre-algebra type thing. We're in algebra. This is high school class. You're in the big time. So we're going to write that as 4 plus 5, 4 combined with positive 5, which obviously makes 9. Subtracting a negative, like adding a positive. Okay? Think of it. If you're carrying a stack of books and each book was considered like a negative 1, if I take away negative 1, or in this case, take away negative 5, I've lightened your load by 5 books. That's a positive. Okay. Our essential question, or our target here for this lesson, is for you to be able to use simple equations to solve real-life problems. Big Ideas is huge into real-life problems, which makes doing algebra way more interesting than our old curriculum that we used up until 2 years ago. So consider yourself fortunate. It's been a lot of fun. We're going to get into some good real-life scenarios. Okay, so vocab. We have some vocab. Go ahead, pause the video, and see if you think you know any of the answers to these, and then we'll go through them. Okay, a conjecture basically is an unproven statement. Okay, so it's like, I think something will be this, but we've got to kind of go through and prove it. A rule, or in this case, or a theorem, they can almost be used interchangeably, kind of, sort of. When you get to geometry or honors geometry, you'll understand what the difference is. But basically, it's a proven statement. So it's something that's proven, okay? What's an equation? Well, an equation is a statement with 2 equal expressions. Remember, an expression is something like 2x plus 5. An expression is something like 6. But if I have 2x plus 5 equals 6, then that's an equation. It's a statement with 2 equal expressions. There's always going to be an equal sign. Okay, what's a linear equation in one variable? Well, it's an equation that can be written in the form of ax plus b equals 0, where a and b are constant and b does not equal 0. So an example of that would be something like if a was 2 and b was 3, it would be 2x plus 3 equals 0. Okay? All right. What's a solution? Think about what a solution is. Solution is a value that makes an equation true. So technically, if I said, what's 5 plus 4, and you said 9, 9 is not a solution because we didn't have an equation to start with. It was an expression. But if it's an equation, so for example, if we had 2x plus 1 equals 3, the solution there is x equals 1. And you can have more than one solution. Okay, inverse operations are operations that undo each other. So think of what would be an example of that. You come up with addition and subtraction, or perhaps multiplication and division. Think about it. If you add 3 to something and subtract 3, aren't you back where you started? If you have a number and you multiply it by 2 and then divide it by 2, aren't you back where you started? Okay, and equivalent equations are equations that have the same solutions. So what did I just say? I said 2x plus 1 equals 3. And we said the solution there was x equals 1. Well, what if I had something like x plus 1 equals 2? The solution to that is also 1. Those would be equivalent equations because they have the same solutions. Okay, so as we go through these notes, you'll see that there are oftentimes core concepts. And they always like to write it in words in algebra. And basically, you can sum this up by calling these the golden rule of equations. Whatever you do to one side, if you do it to the other, you're going to get an equivalent equation. So in words here, it says adding the same number to each side of an equation produces an equivalent equation. So let's say we had A is equal to B. Well, if we added C to both sides, wouldn't we still have equal values? And the same thing for subtraction. If we have A equals B, then if we subtract C or add a negative C, what I like to say sometimes is slap on a negative C to both sides, then yeah, they're going to be the same. So for example, if we had 5 plus 2 equals 7, right? And if I subtract 1 from both sides, what's 5 plus 2 minus 1? It's 6. And if I subtract 1 from the other side, what's 7 minus 1? 6. Golden rule of equations, okay? All right, so go ahead and you guys did this in pre-algebra last year. So go ahead and think about how you would use those properties, addition property of equality, subtraction property of equality, to solve here for x from the first one. And go ahead and do that. And then check your answer. Remember, great thing about equations is you plug your answer back into the original equation to check it. So go ahead and do that. Pause the video. Okay, I'm back. So what am I going to do to get x by itself? I want to isolate the variable. I want to get what x equals. So what would you do first? You'd add 3 to both sides. What happens over here? Negative 3 and 3 are additive inverses, or also known as opposites. So they would cancel out, which is exactly what we wanted to happen. So we can get x by itself on the left side. And negative 5 and 3 is negative 2. Okay, to check it, we're going to plug it in the negative 2. I don't know if you guys have ever seen the Febreze commercials for like air fresheners. They always go plug it in, plug it in. Always reminds me, whenever you plug in, substitute a number for a variable, you always have to put it in parentheses. Super important. Okay, so let's simplify this left side. Is negative 2 combined with negative 3 equal to negative 5? Yes, it is. Check, check. Okay, let's try the next one. So go ahead and give that one a shot. All right, I'm back. So obviously we want to get y by itself. Totally fine if the variable's on the right side. I know, like I'm like, oh, I would kind of like it on the left, but it's okay. We can do it on the right. It doesn't make a difference. So we're going to subtract 2.8 for both sides, or slap on a negative 2.8. Now, obviously on the right side, these are going to cancel. Right, so we're just left with y. And the left side, be careful here. We're combining these together, right? So I always like to say, okay, again, what's the bigger absolute value, the negative sign or the positive sign? Well, negative 2.8 is further away from 0, so it has a bigger absolute value. So then we subtract 0.9 from 2.8, and hopefully you got negative 1.9. Okay, check it, plug it in. And negative 1.9, positive 2.8 is 0.9. 0.9 equals 0.9. Check, check. Just like you're doing a mic check. Check, check. All right. Here's 3 more. Go ahead and give these a shot. Okay, here, obviously subtract 3 from both sides. Go through these kind of quickly. N equals negative 10. And then hopefully you checked it and you saw that it worked. Check, check. Why am I like so stressing that you're checking? Because we all make careless mistakes. You're all good math students, and that's why you're in this class. To become a great math student, the difference between being good and great is catching those careless mistakes that we all make. Over the course of the year, you'll see I'll make careless mistakes all the time in these videos, but that's okay. And I want you to look for those and say, wait a minute, I think he may have made a mistake. And then usually I'll correct myself, but that usually happens when I check. So really get in the habit of doing that. Okay, so what are we going to do in this next one? Got to get that g by itself, right? So we're going to add 1/3 to both sides. Careful when you do the math here. You should get negative 1/3. And then when you check it, negative 1/3 combined with another negative 1/3. Same sign, right? Think of it as addition. Same sign, what do? We take the sign and add them together. 1/3 plus 1/3 is 2/3, so we get negative 2/3, and that's our magic number on the other side. Yay. Okay, last one here, what are you going to do? Right, subtract negative 3.9 and get negative 10.4. Plug it in. This should get us a positive or a negative on the right side. Definitely a negative, and then subtract the 3.9 from the 10.4, and they match. Yippee. Okay, multiplication and division properties of equality. Basically the same thing here. If you have 2 sides of an equation, a equals b, and you multiply a times c and b times the same c, it's going to work. They're going to be equal to each other. Okay. Why do they have c cannot equal 0 here? Think about that. Think about why that would be. And would it really matter? Anything times 0, if c was 0, is equal to 0. So to be honest, I'm not really sure why they have that there. I'll be able to tell you why they have it in the division one. But if a is equal to b, if you multiply both sides by 0, it's still equal to 0. But notice that will work for everything. Again, I call that the golden rule of equations. Whatever you do to one side, if you do it to the other, the 2 sides are, it'll be a new looking equation, an equivalent equation, but still equal to each other. Okay, division property, same thing. If we have 2 numbers like a equals b, and we divide by the same thing c, the 2 sides will still be equal. Okay, let me give you an example of that. If I have 5 equals 4 plus 1, and then I divide both sides by 5, well, first thing, 5 divided by 5 on the left side would equal 1. And if I had 4 plus 1 over 5, I'd have to do the 4 plus 1 first, and I'd get 5 over 5 equals 1. Now, why can't we have c not equal to 0 here? Think about it. If we are dividing by 0, are you allowed to divide by 0? Nope, can't divide by 0. That gives you basically infinity, or it's undefined. Try it on your calculator. You'll see it won't work. You'll get an error message or syntax error or something crazy. All right, go ahead and try these problems. We're solving for n in the first one, x in the second one, and z in the third. And then check your answers too. Okay, so this is negative and then n divided by 5. So what are you going to do to both sides? You're going to multiply. I want to get positive n, right? So I don't want to just multiply both sides by 5. I actually want to multiply by negative 5. And these would cancel, right? This is like negative 5 over 1. So we're left with positive n because we have two negatives multiplied together. And over here, negative 3 times negative 5 is 15. So n equals 15. Plug it in and check. And oops, you end up getting negative, and then 15 over 5 is negative 3. Negative 3 equals negative 3. Check, check. Okay. Now, this looks weird, right? Because it's got a pi there, and there's no number. But remember, pi is just, it's a ratio. We don't know exactly what it is. It's what we call an irrational number because it does not repeat in a pattern, and it doesn't terminate. It's 3.14159, et cetera, et cetera, et cetera. But we can still divide both sides by it. We can divide both sides by pi. So if I do that, these pi's will cancel. I'm left with what? What I wanted to have on the left side, just 1x, or x. Pi's cancel there, and we get negative 2. Okay, plug it back into check. Negative 2 going in for that x. Negative 2 times pi is equal to negative 2 pi. What's on the other side? Our magic number of negative 2 pi. Check, check. Awesome. Okay, do the next one. So divided by 1.3, and hopefully you saw that if you move the decimals over, 52 divided by 13 goes in even 4 times, and if you multiply it by 4 to 1.3, you're going to get 5.2, and that's what our magic number is. Awesome. Okay, here's some more, so why don't you go ahead and do these. Okay, hopefully you multiply both sides by 3. 3's cancel. We're left with 1y or just y. And then negative 6 times 3, negative 18. I didn't check it here, but if you plugged in negative 18 divided by 3, that's equal to negative 6. Okay, here, what are you going to do in order to get x by itself? Hopefully you divided by pi to both sides, and you got x equals 9. Again, I really hope that you're trying these on your own and then just playing this video and saying, yeah, cool, I got it right. And you should know that because you checked it anyway. Notice if we plug in 9 in for that x, we have 9 pi equals 9 pi. Check, check. Okay, what are we going to do here? We need to get 1w. We have 0.05w, so we are going to divide both sides by 0.05. Well, remember, you can always move decimal places over. So this would be the same as 5 on the bottom, and we move that over 2 places. We'd have 140 on top. If you do mental math, I know 5 goes into 120 times. 5 goes into 48 times. So it goes into 140 28 times. Really try and use those mental math skills. It's going to be a lot faster even than punching it into a calculator. Okay, problem solving. So I'm going to tell you a little story here. Way back, this is my 19th year at Brentwood, and way back when I first started, the school sent me to the NCTM conference, the National Council of Teachers of Mathematics conference in Philadelphia. I've actually gone to it a bunch of times since then all over the country, but this one was in Philadelphia. And I went to, there's a whole huge booklet. You go through all these booklet, the seminars in it, and there's just hundreds to choose from. It's like Math Nerd Central, like tens of thousands of math teachers from all over the world actually come. And I went to this one session that was basically about approaches to teaching Algebra 1 students, how to solve word problems. Because that always is like, oh my gosh, it's a word problem, oh no. And this seminar was put on by a teacher from the Houston Public Schools who taught seniors. Yes, he taught seniors Algebra 1. And there's a prerequisite to getting into the class. You know what a prerequisite is? It's basically a condition. And the condition in order to get to his senior Algebra 1 class was you had to have failed algebra as a freshman, sophomore, and junior. So what he came up with was a good approach and realized that what gives kids the most trouble is setting up the word problems and just being relaxed enough to read the word problem, understand it, before you go and then you make a plan. So one approach that he came up with was basically having his kids go to their quote-unquote happy place. So for me, that would be like being on probably on a Hawaii, sitting on the beach with my lovely wife, sitting on Chase lounges, the breeze blowing in the background, and my kids, my two kids, as much as I love them, aren't there. And we're just relaxing and reading and talking and just so relaxing. For you, it might be like a rainy morning on a weekend, cold, and all sports were canceled because of the weather or other reasons, and you can just sleep in, and you got like 4 blankets on top of you, and you can just sleep all morning. Whatever that is, think of what your happy place is. Go there. Why do I say that? Because the stress, the anxiety will come out of you, and then you can focus on the question. Another one that I came up with is, and this is really silly, you actually, when you see it's a word problem, before you even read it, you say to the word problem, hello, word problem, I'm going to solve you now. You probably like smiled or laughed when I said that because it's so silly. But what happens when you smile or you laugh? Your anxiety goes away for a few seconds, and hopefully you can then read the problem. Okay? So read the problem, make a plan, right? Solve the problem, and then ask yourself, especially if it's a word problem, does my answer make sense? Would it make sense that if the question was how many bowls of cereal did Johnny have for breakfast, and you got 18, that obviously doesn't make sense. So you want to check. Okay? So that was your story time. All right, on we go. So let's assign and define a variable. Let's talk about what that means. Assigning a variable means picking one. So in this case, I picked R. A lot of times people pick X's or Y's or whatever. And then defining it is telling me what it means. Then we're going to write an equation, we're going to solve it, and we're going to check. Okay, well, I see it's a word problem. Hello, Mr. and Ms. Word Problem. I'm going to solve you now. In the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed to the nearest hundredth of a meter per second. Okay, so let's see. I have the time. I have the distance. What don't I have here? I don't have the rate. Okay. So that's my unknown, and I know I'm going to use the formula distance equals rate times time. You all probably remember that. Very fond of it, I'm sure. Okay, so I've picked R. That's my unknown. And what is R representing? It represents the average speed, or you could say rate, in meters per second. I always, when you assign and define a variable, you always should put the label on it to help you remember what it is. Okay, so then I'm just plugging in. Distance, I know that's 200 meters, 200. R, and then the time, 19.32. What are we going to do to solve for R here? I hope you said divide by 19.32, excuse me. And if you do that one you can use your calculator. What's it going to be about? 19.32 is about 20, right? And so you should get an answer a little bit more than 10. Okay? And it said round to the nearest hundredth, so we did. Final answer is not just that. You want to label those answers. No naked numbers, right? I don't know. Is it 10.35 rubles? Pennies? Nails? I don't know. No, it's meters per second. Okay. Okay. Now let's suppose Mr. Bolt decided to run 400 meters at the same average speed that he ran the 200 meters. That would probably be impossible, by the way. Usually 400 meters by that point, you're starting to slow down compared to 200. How long would it take him to run it? Now, you might think of doing this in a couple different ways, but go ahead and finish it, and then try setting up an equation, though, with a variable. Okay, so I said x is equal to the number of seconds. So what do I know? I know the rate in this case, right? I don't know the time, and I do know the distance. Again, rate times time equals distance. I just used an x instead of a t. Take x by itself, divide by 10.35. What's the answer going to be about? Probably a little less than 40, right? 38.36. So around 38.36 seconds. And I'm sure that some of you noticed that if it was 19.32 and he's just running twice as far, yeah, you just pretty much double that, right? Oh, by the way, notice I made a careless mistake. I rounded the nearest tenth. I should have rounded to the nearest hundredth. Oops. Okay. So again, using these strategies, super important. As you go through word problems, we're going to use various, strategies such as these throughout this class. Okay, here's an interesting one. On January 22, 1943, the temperature in Spearfish, South Dakota fell from 54 degrees Fahrenheit at 9 a.m. to negative 4 degrees Fahrenheit at 9:27 a.m. How many degrees did the temperature fall? I really want you to try this one on your own. Again, assign and define a variable, then write an equation, solve, and check. So go to your happy place. I'm actually thinking of Spearfish, South Dakota. I went there one time, way back in the late 90s. Beautiful place. And it was in the summer, so we didn't have temperatures like this. Okay, so what's unknown? The number of degrees that the temperature fell. So I use T. T is kind of a tough one. Sometimes it looks, it's hard to tell exactly what a T looks like. But anyway, I went with T for temperature. So what would your formula be? Or your equation, excuse me. Well, one way to set it would be 54 minus the drop equals the resulting temperature. And if you did it this way, what would you do to get T by itself? Well, one way to do it would be to subtract 54 from both sides to isolate this term. Does that get us T by itself, though? Not yet. We actually have negative T equals, and then we would combine these, negative 58. What would you do here? If the opposite of T is equal to negative 58, wouldn't that mean that T itself is equal to positive 58? Technically, we could multiply or divide both sides by negative 1, golden rule of equations, and we'll get 58. Okay, so your answer is 58, and that's a degree symbol, not an exponent to the 0 power. Okay. All right. You thought the balance in your checking account was $68. When your bank statement arrives, you realize you forgot to record a check. Uh-oh. The bank statement lists your balance as $26. Write and solve an equation to find the amount of the check that you forgot to record. Okay. I know that you're thinking, oh, wait, I can just subtract 26 from 68, and that should get me the answer. You're not wrong, but I really want you to practice assigning and defining a variable, setting up an equation with that variable, and solving it. Do that. Start with the easy ones, work up to harder ones. Okay, so I said X is the dollar amount not recorded. So obviously, I would go one way, 68 minus 26 equals X, or I could have done 68 minus X equals positive 26. Either way, you end up getting 42, and that is your answer. Okay, so I want you to take a second. I want you to describe in words how you would solve a one-step equation. Okay, so one-step equation is something like x plus 3 equals 12, or 4x equals 16. So go ahead and do that. This is what I wrote. Use an inverse operation to isolate the variable, right? If I had x plus 3 equals 4, all I need to do is get that x by itself by subtracting 3 from both sides. Okay, and then go ahead and solve this one. Negative 13.8 equals x minus 4.3. Okay, we're back with you. Hopefully you added 4.3 to both sides. What are we going to do here? What's our answer going to be? What's our sum going to be? A negative, and then subtract the 4.3 from the 13.8. And you get negative 9.5. All right, terrific. Keep those notes in a notebook. We've probably talked about that already, or we will shortly in one of these first days of class. And go ahead and go start your quote-unquote homework if you like, or we'll, when it's assigned to you, or we'll do it in class. We got one down, a bunch to go, but it was all good.